6.7, our last section. Okay, just one page, just 2 questions. Here we go. Here are formulas that we have reviewed. These are all reviewed. So this is your distance formula, your midpoint formula, your slope formula. We want to use this when these things are what it's asking. So one thing, I'm going to focus on these when I'm dealing with a quadrilateral. I'm going to focus on the diagonals, and we'll get into that. But these are different things that you can use when you're given, like this first one. Saying you have a triangle, the points are R, S, T. Is it scalene, isosceles, or equilateral? You could definitely try to graph this out, but it will be precise. Scalene means that there's no sides that are equal. Isosceles meaning that there's 2 sides that are congruent. Equilateral means that all 3 sides are congruent. So what we have to do is we have to find the distance in between each point. The hardest part with these problems is just staying nice and organized. So we have RS. So I'm going to write out the points to RS. So -4, 1, and S is 3, 3. We have so this is a length R to S. We have a length to S to T. So S is 3, 3. T is 1, -3. And then we also have RT. So these are our 3 lengths in our coordinate grid, our X, Y axis. For you people who enjoy algebra, here you go. So I'm going to use my distance formula. So using this formula for all of them, because we need to find the distance of each length to see if all the sides are the same, if 2 sides are the same, or if no sides are the same. So it's saying your difference of x's. So I'm going to have x minus x squared plus y. Oops, sorry. X minus x, y minus y squared. Now, when I do this, this would become 49 plus this becomes 4. So this is the square root of 53. I'm going to leave that as a root. I want you to pause the video and I want you to do ST and RT. I want you to find the distance between both of those 2 points with your distance formula. And you should have got the square root of 40 and square root of 41. Now here's the thing. If I were to plot these 3 points and just look at the image, I might have thought that this is an isosceles triangle because these 2 lengths are very close together, but they are not the exact same. They need to be the exact same. So you have to find the distance. So this triangle, because all 3 sides are different, are scaling. Okay, scaling. So now we actually are given a quadrilateral, and we want to see if this shape is any of these that are in this list. So I'm going to actually focus on the diagonals of this quadrilateral because it's a little bit shorter. Because if I wanted to figure out the side lengths and the slopes of each side, I'm going to have to do a lot more math. So I'm going to figure out the diagonals. So first I'm going to draw this picture. Remember, when you draw a picture, you have to make sure to go in the order A, B, C, D. So I'm going in a clockwise order when I'm naming that shape. So when I'm looking at my diagonals, I have diagonal AC. So I'm going to write down AC. My point for A is -3, -4. And my point for C is 5, 2. Now I'm going to look at BD. So BD is my other diagonal. So BD, the point, again, this is just trying to make sure that I'm staying nice and organized. And then D is 4, -5. So what we're going to do, we're going to find the distance, the midpoint, the slope for each one of these 2 lines. So first we're going to find the distance of AC. So I want you to pause the video since we just found the distance. I want you to find the distance first. So find the distance of just AC first. And you should have got the square root of 100. This one's 10. So again, I'm only going to focus on AC first because then I'm going to pause it and you're going to do all 3 for the other one. So now I'm going to find the midpoint. So again, reviewing my adding my x's, divide by 2, adding my y's. When I'm looking at this, my midpoint is adding my x's, divide by 2, and adding my y's, divide by 2. So this becomes positive 2 over 2, which is 1, and positive or negative 2 over 2, which is -1. So finding the midpoint. And now I'm going to find the slope of that line. So if I look at the slope, it's the difference of y's. So again, I'm focusing on these 2 points each time, focusing on my AC points. That's why I wrote them down here. My difference of y, so -4 minus 2, -3 minus 5. So this becomes a negative 8 over negative 8, which is equal to 1. So now I want you to pause the video and find the distance, midpoint, and slope of BD, and then we'll analyze it. So what do we have here? You should have gotten that your distance was also 10, that your midpoint was also 1, -1, and that your slope was a -4/3. So what is this actually telling us? Well, we know that our two diagonals, our distances are the same. If the distance of your diagonals are the same, we have the option of either it's going to be a rectangle or it's going to be an isosceles trapezoid. Those are our two options because of this. This one, now our midpoints are the same. That means that when those two diagonals crossed each other right here, it was both at the center of the line. That's saying that this is going to be congruent and these two would be congruent. So the diagonals bisect. So if the diagonals bisect, that means this is a parallelogram. And right here, my slopes are not the same, nor are they perpendicular. This would tell us if the slopes were perpendicular. If the slopes were perpendicular, this would be a rhombus. But because they are not perpendicular, we don't have anything. So we know for sure it's a parallelogram because of this. But because these two sides, because these diagonals are the same, then I know it's not an isosceles trapezoid because I know for sure it's a parallelogram. So if it's a parallelogram and the diagonals are congruent, then this is going to be a rectangle. So this answer, I'm gonna write rectangle, final answer. That is my answer. Bing, bada, boom. I know, lots of math, lots of fun. But we'll be reviewing this in class also. Have a great, grand, wonderful day.